Characteristics of liquid pressure. The deeper the liquid, the faster the liquid spurts out. Okay, it's talking about this experiment, okay? So these experiments, we have a container and then we make 3 holes at the container. We found that the hole at the lowest, the lowest hole, okay, the water spurts the furthest, okay? It goes the furthest compared to the other 2 holes, okay? And the highest hole, okay, it spurts the closest to the container, okay? So from this experiment, we can conclude that the deeper inside a liquid, the higher the pressure. So deeper, it has higher pressure, and shallower, it has lower pressure. So the conclusion, the pressure in a liquid increases with depth. The deeper inside the liquids, the higher the pressure. Okay, so these experiments tell us that pressure increases with depth. Shape, size, and area. Pressure in liquid does not depend on the shape of the container. You see here we have 3 containers with different shape. You see the height of the liquid is the same, okay, for these 3 containers. Okay, means that the depth at these 3 points are the same. Since the depth are the same, so therefore the pressure are the same at the bottoms. Even though these 3 containers has different shape, it doesn't matter, okay, it doesn't matter. And also you can see that the area is not the same. This one has a smaller area, this one has a bigger area, okay, but still the pressures will be the same. The pressures of the liquid will be the same at the bottoms of the container. That is the pressures of the liquid. Okay, if they ask a pressure exerted by this container on the table, if this is a table, okay, then they will be different. Okay, pressure exerted on the table and pressure in the liquid is not the same. Okay, I will discuss that later. So pressure in liquid does not depend on the shape of the container. Big, small, okay, any shape. As long as the depth is the same, then the pressure is the same. Pressure in liquid does not depend on the size of the container. Okay, big container, small container, okay, these 2 the shape is the same, okay, shape is the same, but this one is much bigger compared to this one, but still the pressure will be the same at the bottoms as long as the depth of the water is the same. So pressures are the same at the bottoms. Okay, so pressure does not depend on the size, it does not depend on the shape. Pressure in liquid does not depend on the area of its surface. So we have 2 containers, okay, and then we have 2 objects, A and object B, two different areas, okay. A is smaller than B. Area A is smaller than area B, but the pressure exerted on area A is the same as the pressure exerted on area B. It's the same, okay. So pressure in liquid does not depend on the area of the surface. Bigger surface, smaller surface, the pressure is always the same. So we can conclude that okay, pressure in liquid does not depend on the shape, it does not depend on the size, it does not depend on the total area or surface area, okay, of the object. Yeah, that's the conclusion that we can make. Pressure depends on the vertical depth. Okay, now let's see these 2 examples. Okay, so this one is vertical, this one is slanted, slightly slanted. Okay, if we compare the length of the liquid, this one is longer. Okay, the length of the liquid. The length of the liquid is this. Okay, let me write here the length of the liquid. Okay, this is the length of the liquid. This is the length of the liquid. This is the length of the liquid. Let's say this is L2 and this is L1. So in this case, L2 is longer than L1. L2 is longer than L1, but they have same vertical height, okay, or vertical depth. The H is the same. H is the vertical depth. So pressure depends on the vertical depth. So even though these 2 water has different length, okay, different lengths, but their pressure at A and B are the same. Pressure at A is equal to the pressure at B because they have same vertical depth or vertical height. So pressure depends on the vertical depth. It not depends on the length of the water column. Okay, it's not depends on the length of the water column. It depends on the vertical depth. So pressure depends on the vertical depth, but not the length of the liquid column. That's very important for you to know. All points at the same level has same pressure. The levels of the pressures of a liquid in a container is always the same because for the given liquid, the pressure is always equal at the same level. These experiments, like if you make 3 holes at the same level, you will find that the distance where the water spurts out are the same. Okay, the distance are the same. If this one is 2 cm, okay, if this one is 2 cm, then this must also be 2 cm, and this distance must also be 2 cm. This shows that the pressures are the same. Okay, and this experiment also shows that pressure at the same levels are the same. Okay, because you see the levels of the water is the same, even though the surface area and the shape are not the same, but the levels are the same. This shows that the pressure are the same. If the pressure are not the same, if the pressure here is higher, it will push the liquid down. If push the liquid down, then this level will be lower. Okay, but this is not the case. They always have the same levels at the same level. So this shows that the pressure is the same at same level. So liquid surface all at same levels. So all points at the same level has same pressure. Okay, as long as the levels are the same, then the pressure are the same. Pressure does not, okay, there's a typo here. Okay, does not depends on the surface areas of the object. So we have 2 fishes here. As we do the calculations in the previous examples, we found that at same levels, their pressure are the same, even though this fish is much bigger than this fish. Okay, so pressure exerted on the small fish is equal to the pressure exerted on the big fish. Pressure acts in all directions. The pressure at any points of a liquid acts equally in all directions. So the pressure acts the left hand side, the right hand side, on top and below. The pressure are always the same at the same point. So pressure at any point, a liquid acts equally at all directions. Okay, pressures to the left, pressure to the right, pressures on top, pressures below are all the same at same level. Okay.